about yourself?
Yeah, hi everyone, and sorry for all the technical difficulties we had this morning. About me, I'm a senior technical architect. Okay.
Please go ahead.
I'm doing integration for last 20 plus years, back from the TIPCO days. And for the last 8 years, I'm doing MuleSoft, and I'm a MuleSoft certified integration architect. I work, I'm from Extivia. We are a integration and enterprise information management company. We are a premier MuleSoft partner for the last 8 years. If you have any integration, if you can think of an integration scenario or in a business scenario, we can solve that.
Thank you so much, Mani, for brief description. So moving forward, we can start discussing about the topic and demo. So I'm going to stop sharing, and Mani, you can share your screen and you can talk about the topic. Hello, Mani. Hi, Mani.
Did I?
You are breaking, Mani. Mani, you are breaking. We cannot hear you. Hello, Mani.
Is it okay now?
Yeah, it's better now.
Oh, sorry. Yeah. So what I was saying, where I'm not sure when I got disconnected or something. So what I was saying, like I have 20 plus years of experience in integration, and in MuleSoft, it's last 8 years. I'm a MuleSoft certified integration architect. I work for a company called Extivia. We are a premier partner for MuleSoft for the last 8 years too, and we have a pretty mature practice around MuleSoft.
Thanks, Mani, for details and your introduction. Can we start
Yeah.
topic? And yeah, I just handing over to you. You can share your screen and you can present the topic.
Yep. Okay, so let me just brief what's the plan for today. You can see my screen, right?
Yeah.
Do you see a split screen or a complete screen?
It's a split screen.
Split?
Yeah.
Okay. Yeah, then. Okay, just put that. That's what happens if you see both window. Anyway, so here is our plan for.
Mani, cannot hear you.
Can you?
You are breaking in between.
Wow. Hello? Is it okay?
Yeah.
Okay, let's get started. We have some noise coming from
Yeah.
Yeah. Okay.
Yeah.
So so the plans. I think it's already 19 minutes we lost. So here is the agenda for today, and I won't. We'll just go straight to the agenda. So if you see, so we're going to talk about Anypoint Runtime Fabric. So just to give you a brief introduction before we go over to that slide. So you guys have you experienced Cloud Hub, right? I mean, you have used Anypoint on-prem with an installation. Also, you have used Cloud Hub. So what you get in Cloud Hub is a containerized environment. You don't see that, but that's something MuleSoft does for you, where you kind of get a application isolation. So the main factor, our main reason people choose Cloud Hub is a couple of things. Right? One is where you kind of don't manage the infrastructure for MuleSoft, and which includes the runtime, the upgrades, and all. And then also you would like to get a isolation of application. So what happens in an on-prem application? So let's say you have a like a 2-core or 4-core environment, and let's say you have 30 applications deployed there, and if one application bloats in terms of CPU or memory, it's going to eat up other space, right? So then it's pretty much will choke other applications. So it'll kind of use up all the resources available to it. So that's why the need for Cloud Hub, where you want to get a stricter application isolation, because in Cloud Hub, what happens is like your application, when you deploy it to an isolated container, which includes your application plus the Mule runtime, right? It's packaged, and also you can scale, and you can assign your replicas, which is the number of instances running for your application, so you can scale in. We have all that feature, right? So one thing I would like to appreciate in Mule is like, so Mule has always adopted the way customers are kind of moving in their digital transformation. It started with a on-prem. Then when the people are very familiar with on-prem, doing stuff on their own data centers. Then when the cloud stuff kind of modernized, and then people are new to cloud, and then MuleSoft took a leap and then provided the Cloud Hub architecture, which is kind of taking all the headache of the cloud, but you do everything Mule, but without the nitty gritty of how things are done in the cloud, right? So that was Cloud Hub. Then for some customers who cannot go to cloud for various reasons, right? For like say from regulatory, you are a healthcare company, you cannot go to cloud, or you cannot go to because MuleSoft Cloud Hub is on Azure, sorry, AWS or Amazon, right? So you cannot leverage that because of some competitions with Amazon or something. So and some data privacies and all that. So many customers choose to stay in their data center, right? For them, now Mule has launched something called Runtime Fabric, right? Where you get all the feature of a cloud of things, right? So which is pretty much scaling up and application isolation, containerized environment, all that good stuff about cloud up, but you do that on your own data center. So that's where Runtime Fabric came in. But again, that also has, and again, when we're talking about runtime fabric, right? There are two things here I would like to mention about. One is where you do complete. Let's say you have, you not have expertise in Docker or Kubernetes, right? So then the runtime fabric has an offering for it's called the bare metal or VMs, factor. So where you don't have to manage Kubernetes behind the scene. It's all done for you. So that's the RTF on a pretty on an appliance mode where you kind of the metals, right? You just put that on a VM or a typical physical server, and then as and when the companies kind of moved through their digital journey, right? And many of the companies today are already in different public clouds, be it in Amazon or Azure or in a Google Cloud. So pretty much people are in different phases of their cloud migration journey, right? And an integration becomes just quote unquote a component of their overall IT architecture, where they were using MuleSoft or they were using some other tools or on-prem. But if your IT shop is running or powered by Azure, and you may or may not want to have an integration layer outside of that environment, right? Because you pretty much every one of your systems are in Azure, right? It doesn't really make sense to have your integration layer outside of that, outside of that ecosystem, right? And but at the same time, you want to get that cloud, quote unquote, cloud-like feel of you know on your environments, right? I mean, on your application. So that kind of created a need for kind of a launch a runtime fabric on self-managed Kubernetes. So what does it mean? That so Mule is pretty flexible enough to kind of provide you a, because if you're already in one of the clouds I mentioned, AWS, Azure, or Google, and you already have experience running a Kubernetes platform, right? I mean, you already have a lot of your Java applications or any of your data applications running in a Kubernetes cluster, and Mule happens to be part of that ecosystem. And in that case, so Mule is offering a flavor of runtime fabric. Think of runtime fabric as a cloud-like feature, right? Which has everything you always expect from a cloud-like application, right? Or cloud-native application, so to say. So it has all the things, it provides you all the things, but in this flavor, it kinds of provides you a Kubernetes flavor, like which will well integrate to your existing Kubernetes cluster. So so let's so just to summarize here, Anypoint Runtime Fabric is a container service which allow you to run Mule applications, APIs, API gateway. Because see, it's all Mule runtime, one runtime, right? You may use that as a API gateway, or you may use that as a platform integration. It's up to you, right? And again, all the features what you typically expect from a cloud native applications, isolation that I talked about. Want to do a multiple version of Mule runtime, well and good, you can do that. You can scale your application across multiple replicas. Great, that's what you do that in Cloud Hub. You can do that here too. And automated application failover, because all the time your applications are running on a kind of a active mode, right? So you get that failover or a high. I won't use the word failover. I'll use the word high availability, because your applications are always available. Doesn't matter you fail over, so it's not about that. It's all active. It's highly available to you or to the customer. And you get that application management with Anypoint Runtime Manager, which is the control plane of the Mule. So what are the flavors? I just talked about the two flavors, right? One, so think of Runtime Fabric as a cloud-like feature, right? So and then the two versions I talked about. One is the bare metal or VMs, right? For people who do not have sufficient expertise in Docker and Kubernetes, and they don't want to manage that the behind the scenes stuff around Docker and Kubernetes, right? So you go for and then if you have any regulatory reasons or something, you cannot go to one of these public clouds. Yeah, go ahead with a runtime fabric on a VM and bare metal. You get that option. And as I mentioned, if your IT platform is already running in one of those, the number one is when you go for a self-managed Kubernetes. So here, your IT platform is already running on or powered by any of these public cloud vendors. Now you choose, and you're already doing a lot of Kubernetes in your IT infrastructure. Then yeah, please go ahead with one of those Kubernetes flavors you have. You can do runtime fabric on a Azure Kubernetes or a Elastic Kubernetes Service EKS or a GKE Google Kubernetes Engine. So it's all supported there. So basically, pretty much what I'm trying to say here, like you pretty much bring your own Kubernetes flavor from this public cloud, and then Mule supports that, and then you have your Mule environment for that. Yeah, I was talking about that. In what scenario you go for a self-managed Kubernetes, or you want to go for a bare metal VM Kubernetes? Sorry, runtime fabric. But let's talk about what is supported in each of these flavors. Um, so the major difference, if you see here, just a second. Okay. So just give me a sec. Yeah, you can see my full screen, right?
Yes, Mani, we can see his screen.
Okay. So I mean, pretty much, if you look at talk about support for deploying mules and API gateways, yes, it's both supported, and Kubernetes and Docker. Um, so the first one, you bring your own So for the Kubernetes and Docker, so pretty much you in a self-managed Kubernetes, you bring your own Kubernetes, right? Be it EKS, AKS, or GKE. Whereas on a runtime fabric on VM and bare metal, it, like we will provision that for you. You don't have to worry about what is the underlying Kubernetes and architecture, Docker architecture. You don't have to worry about that. And for installing on an Linux in distribution, it's both supported. Yeah, and one key feature what you see here is the node auto scaling. We all know application auto scaling, right? You have your replicas, you can scale it. But if you notice or not, you um, node auto scaling is not supported by runtime fabric. Let's say you already have, let's say, two node, and your load increases there, and for some reason you have a spike. The nodes won't auto scale. Nodes won't be provisioned for you automatically in runtime fabric. But whereas in self-managed Kubernetes, because think of this way, all Mule doing here is providing you a containerized or Kubernetes supported environment here. The clusters are being provided by or GKE, right? So when you talk about the clusters, the Kubernetes cluster meant here, I mean that is automatically a feature of those public clouds, where the node autoscaling is a feature of AKS, EKS, or GKE clusters, not a feature of Mule, because Mule is just pretty much on an application side. The infrastructure is being managed by all these public clouds. So node autoscaling is a part of an infrastructure feature, not an application feature. So it's already given default by that Kubernetes cluster. External log forwarding, and we'll soon learn why it is critical. I'll talk more on that when we go there. And the internal load balancer. So this is something interesting. I mean, we'll spend a little bit time on this. We think of this way, right? It's a cluster, right? Where clusters will have pods, and when a traffic comes, someone has to redirect. Okay, here is the pod running your application, hello world, and go and hit that traffic, right? So who does that work? Because clusters has many pods. Somebody has to redirect the traffic, right? When it hits the cluster gateway. So that's where you need an internal load balancer, which will redirect the traffic. It just not just redirect the traffic. It also does a kind of a bit of a lightweight security, I would say. It does security, it does traffic routing. All that is done by that internal load balancer, and we will spend a good amount of time today on that. And then finally, Anypoint security edge. It says not supported. So think about it. Like again, I'm going back to this point. Like you are just riding. Just think about Uber, right? You're riding Uber, you don't have to worry about like how to maintain the car, right? You don't worry about the filling your tank, right? That's not your worry. You don't worry if there is a seat belt is there or not, right? I mean that's already supported by default, right? You don't worry if the car has I mean you really worry, but again what I'm saying, like it's already pre-packaged. I mean that's like minimum standard where you get to a Uber or a Lyft kind of thing, right? So similar here, the Anypoint security edge, it's a security feature, right? Your security feature are already given to you by the cloud provider. They have many. You don't have to worry about that. Whereas if you do a runtime fabric on a VM or bare metal, you really have to think security, right? Because you have to really think about the security for the overall RTF environment. And then in that case, we will already package that with you with that installation, so you don't have to worry that. Um, Again, Op Center is a feature which is in the runtime fabric for the VMs or bare metal. You don't need that typically, because again, the same stuff. I quote an example of the Uber and Lyft. It's a monitoring thing, right? And it's already being provided by your public cloud vendor. So you don't have to worry about that monitoring and alerting, all that feature. You use what comes default part of your cloud provider. For example, Azure Monitor, which does the job for monitoring your containers. It has a log analytics workspace. AWS has CloudWatch. Google has its own. So everyone has their own monitoring tool. So all Mule has to do is be just quote unquote another container running in the overall cluster. And whatever tool is out there for those public cloud, you just use that. So you don't have to use the Ops Center, which is specific for Arenta Fabric on a bare metal. Any question?
Mani, there is a one question by Amit Arora about about the cost of the license of all the setup for that year.
Okay. Yeah, let me look him or something. Yeah, so the cost of license, I think, new license are not a price stuck on your product, right? It's pretty much vary depending on what the lot of factors goes in behind the scene for a licensing cost. I mean, I won't be able to quote that price because you have to talk to your mule partner and they can work. Um, I mean, they can work with a customer success manager and then they can figure out the pricing. It's not a sticker price you get in Walmart kind of thing, right? So it's different. It
Yeah.
varies.
Hi, Mani. Amit this side.
Hmm.
Like as you shown the example, even in the last one, with the Azure cluster and like Nginx controller. So even for that, like if you give the rough estimation, like whether we required the license or the payment for the Kubernetes, like even for the Azure, when we are making the cluster or when we are having the Nginx or HA proxy. So if you give that, okay, whether we required the payment or license for those, because we have very less experience in Kubernetes. We are mostly in the MuleSoft. So
Right.
if you give some idea that, okay, when we are doing these setup, we require this license and that will
Okay.
give us proper idea.
Right. Yeah, I can speak on that. So, your Mule license is based on the codes, and the codes, it doesn't matter. Once you are licensed for Mule, let's say a 2x4 configuration, where you get two development codes and then four production codes, right? Which is pretty typical or pretty standard to start with the licensing, right? So Mule doesn't really care about whether you are taking that license to a Kubernetes cluster or you're doing that with an RTF on-prem. It really doesn't change much, right? And then here, if you're thinking on a Kubernetes, right, on Azure, which we'll be talking today, so you are paying for the clusters to Azure, right? Your Kubernetes cluster has certain number of nodes, and you pay to Azure for your usage, right? And so that's a cost you have to work with Azure. And for Mule, as I said, it's already licensed based on your number of cores, a 2x4. You already have agreement with Mule on that. And coming to the Ingress controller, so when it comes to Ingress controller, right, you have pretty much a wide choice. If you talk about Google, Google has its own internal Kubernetes. I mean, they have their own Ingress controller. You can leverage that. You pay Google for that. What I'll be showing today is Nginx. Nginx is it's an open source controller, right? And you don't pay. So to answer your question, you don't pay anything for an Ingress controller or an HA. I mean, Ingress controller from Nginx. It's an open source. Either you can go from, I mean, the one I'll be using is from the Kubernetes community, which is free. And then there is an Nginx app. You can get that from Azure and then configure that. So Mule is only concerned, and then we'll shortly see who does what. I mean, like the pricing part comes into picture, right? When you know who does what. So what is the responsibility of the customer? I mean, I'll just take you to this line here, right? If you look at this slide, Amit, so these are the things MuleSoft manage. And when we say MuleSoft manage, you pay to MuleSoft for that. The blue stuff is what you pay Mule, right? Your runtime fabric components, your the deployment resource and all that. But if you look at the customer managed, is what you are responsible for it. For example, Ingress Controller. Either you have choice there, you go with a paid one, or you go for a community one, right? And log metrics, if you're leveraging Azure Monitor, you pay Azure for that, or any of the node pools. Node pools are pretty much your, like your nodes, which are pretty much a physical, I mean, a VM basically, or a machine. You pay based on your number of nodes you're leveraging. Disk, same thing. What kind of disk you are, it's all you're paying to Azure on the bottom side, because that's the customer responsibility or customer managed, right? And the blue one is what you pay to Mule. And as I said, you pay Mule irrespective of whether you're doing the RTF on-prem or RTF on Azure. It's the same pricing model. Does that
Okay. Yes.
okay? Yeah. So this is where I would say a lot of discussion will happen. Before I head to demo, so I'll go back to the architecture. So if you look at this slide, right? I mean, you have seen. So if you see, right, you see on this first on the top, which is managed by the MuleSoft, you see the top service here. You see all these nodes. You have the network, and you have all the nodes. All these nodes are in Azure term we call them as a node pool. Let's say you want to host a cluster which has 4 nodes or 5 nodes. Based on your sizing requirement, you have all these nodes, and in each of these nodes you have your applications packaged with your runtime engine. Because see, that's the common architecture between a cloud hub and a runtime fabric, right? Because it's all application isolation and in a containerized environment. These two are the common thing, right? It doesn't matter you do that on EKS, AKS, GKE, or you do that on your plain VM. It's the same thing. Your application is isolated. It's packaged with your, it comes bundled with your runtime engine. You put that in a node, right? And then you scale your node as you need. So these are common. And then you see this horizontal line cutting across these nodes is your runtime fabric services. So I will show you what are the services we're talking about. The critical feature here is the runtime fabric agent, the RTF agent. So that agent is, if you guys come from the good old days of things, right? There is an agent-based architecture. Many of the softwares run in an agent-based architecture, right? The agent will be running in all those machines, and it will be sending a status to some centralized servers, and that's how they're connected. It's an agent-based architecture, right? So it's same thing here. Runtime fabric is an agent here. We'll see that, and that agent runs in all of these nodes. That's how they communicate with each other, right? And on the bottom, what you see is your in a cluster here, right? Because and if I show you if I just rename the slide and say runtime fabric on VM bare metal, all I have to do is like change that EKS, AKS, GKE. I just say Gravity. Gravity is a flavor of Kubernetes, and it has a cluster, a Gravity cluster for that. Nothing else changes when it comes to the architecture side. Okay. Okay, so just take a time to go through the demo outline. So what we're trying to do here, we'll create an EKS cluster, and then we'll install runtime fabric on AKS cluster, which is the Azure Kubernetes services cluster. And the critical critical component we'll be touching upon today is in configuring an Ingress controller, because installing runtime fabric is just it's a charm. It doesn't take much time, and it's pretty easy. The focus is on bringing that Ingress controller, because if you remember this slide, Ingress controller is the responsibility of the customer, and because the top part is pretty seamless, it doesn't take much time, and you'll see that. Um, Getting a cluster ready takes a time. Configuring Ingress takes some time, and then we'll do deploy an application, just a basic hello world application, and then we'll secure the traffic, because see, we need to secure the traffic from from the client all the way till the backend, which is our Hello World application here, right? So we'll be securing the traffic. So I'll show you two sides of the security, and that's number 5 and 6. And then at the end, we will just uninstall and clean up, right? We don't want to. I mean, I don't want to keep billing Azure for the whole thing. So I'll just do a uninstall and clean up so that you know how to reset the slide. Oops. Okay, so this is what we are trying to do. If you look at this architecture here, this is what I'll be demoing today. So ignore the Azure load balancer for a moment. So we'll be focus on the cluster on the right hand side, and I'm going to use Nginx, an open source Ingress controller, um, and open source Ingress controller, and from that Ingress controller, the traffic we are securing to the pod, right? These pods are where our MuleSoft applications are running, and the traffic we'll be securing is between the client apps and the Ingress controller, and that's number 5 in the previous slide. And then we'll be securing the traffic between the Ingress controller to the Mule application. So at the end, you have a complete end-to-end security of your traffic. And see, coming back to AKS cluster, you see the Kubernetes cluster here, and then you see it's all part of a virtual network, and this is being in a different subnet, and these are standard for AKS clusters. Any question?
Yes, Mani. Will you guide us how to configure the Azure load balancer also?
That's outside the purview of the demo. I mean, yeah, I won't be speaking on that. It just like when you create a cluster, it's yeah, I'm not going to talk about that. It's something um, outside the scope of today's demo. But again, these are all Azure features. So there are many features you can bring into Azure here when it comes to securing that front end traffic. The Azure provides a host of things to do that. I mean, starting from NSGs, firewalls, a lot more you can do when it comes to really locking down your infrastructure. So and routing traffic. It has a host of services, including DNS. So yeah, I won't go in that direction. So again, the focus is on the blue part here, because assume that I mean, I'm going to touch upon that Ingress controller, but that's about it.
Okay.
Yeah, we'll be doing a Azure demo today instead of doing a MuleSoft demo.
Okay.
Okay, so let's get started. So what we need before we get started, we need 4 things, right? 5 things, in fact. Anypoint platform, you can always get a free trial account, so don't have to worry about if you're trying on your own. Get a free trial account and just play with it. And Azure CLI, this is your cross-platform command line tool. You just download that, install. It comes with a different various flavors. You can put that, Unix or a Windows MSI package. You have a lot of choices there. The same thing for kubectl, which is a command line tool for working with Kubernetes cluster. So that's your basic command for Kubernetes. Same thing for rtfctl, for this command line tool for your runtime fabric. And at the end, the optional thing is a curl command. It'll be, I mean, I'll be using today, but you don't have to. Just get a curl command and then so that you can just ping that URL. Or you have Postman, you can use any, you're free to choose anything. But the top 4 are a must. Okay, so let me head back to the demo. So first thing is we need to create, remember, we need to create a cluster, right? So this is my Azure, and if you look at, so first thing you do is create a resource group, right? Before you do anything in Azure, you create a resource group. It's pretty much kind of a container, or think of like a bucket, or some like a grouping of all the resources you would like to create, just like a home basically for all the things you're going to create. going forward. So I have created a resource group called RG MuleSoft RTF demo, and inside of that I have created a cluster, and which is a Kubernetes cluster for in Azure Kubernetes services. If you zoom in, and the commands are, you can do many ways. You can go and then right click and like here, if I want to do a create, just do a create. It takes time. So I already created this before. I don't want to create a resource, but I already created. So if I go here, then just create, and then all you have to do is like type Kubernetes, click Kubernetes service, and then when it's going to create, it takes like 15-20 minutes. I already created that for you guys. So here is my cluster. So okay, so if you see here, I'm creating a cluster in East US location, and I'm selecting Kubernetes version 1.21.7, and this is something you need to really pay attention and kind of look through the release notes, because by the time you will be doing this on your own, the version might have changed, right? And so go to MuleSoft, go through the documentation for RTF and see what Kubernetes versions are supported. Not everything is supported. In Azure has like AKS has higher versions, but for RTF 1.12, the version of Runtime Fabric we're doing today is 1.12, and it only supports version of Kubernetes which are 1.21.3 or later. Later in the sense only from the 1.21.x. Even though there is a 1.22, I think there is a 1.23 or something, but it doesn't support all that. And I had issues trying that out. So I went back to the 1.21, and 7 is the available version here. So I have selected the minor version as .7. And if you see here, I'm doing a node pool. So remember that diagram here, like you had a right. This is the node pool, right? So you have in this diagram you see 3 nodes, right? For demo purpose, I have selected a 2 node. So if you see here, node pool which has node count 2, so 2 of 2 is ready. Then if you see here, I have 2 nodes, right? And if you see here, a scale method. So, and this is a feature of Azure, not a feature of MuleSoft. Like auto scale. If I select auto scale, remember I was talking about the difference between a runtime fabric on a VM or runtime fabric on a Kubernetes cluster. The node auto scaling is not supported in the runtime fabric for VM. But whereas you see here, scaling nodes, if you select here, it will automatically scale. I'm doing it manual for the demo purpose, but um, but recommended is auto scale, right? And look at this virtual machines. What I've selected. It's the all you'd care about is the standard DS2 V2, which is a configuration, and which that means you have a 2 vCPU, 7 gig memory. Anyway, so okay, these are all Azure features. I won't dwell more into that. Let's head back to the Mule stuff. And I think I had a command I can show you. So these are the commands. So if you want to create a Azure cluster, first you create a resource group, using AZ group create and name and all that, location east west what I'm showing, and then second you create a cluster, right? It takes 15-20 minutes. AZ AKS create, where you see a resource group you have assigned, which I have already created in the previous step, which is RG MuleSoft RTF demo, and I'm naming that cluster as AKS MuleSoft RTF, and here I'm saying node count 2, right? And Kubernetes version you have to supply, which is 121.7, and a node VM size. This is a pre-packaged configuration. So all I have to select is which size I'm going to select, standard DS2 V2. And there are a lot of D series, B series, a lot of series are there. So I just selected a D series DS2 V2 because that suffices my need. And then the first thing we'll do is, now because remember, you have just installed a Azure CLI, right? And you have configured all this. You already created a resource group, you created a cluster. The second thing is the third thing is just to get a get the credential. So because we're doing everything from your CLI, right? So you need to, anything you operate, it goes into that kube config file, which is pretty much maintaining all your credentials. And next, so now your infrastructure or the cluster is ready, right? Now let's head back to Anypoint Manager, and where we'll be creating a runtime fabric. So this is my runtime Anypoint Manager. Sorry, Anypoint platform. I'm heading to runtime manager. So runtime fabric. I'm selected. Dev is my default environment when I log in. And if you see here, go to runtime fabric and create a runtime fabric. And here you see this different flavors which I just talked about. The top three are the Kubernetes flavor. With three different public clouds: Amazon, Azure, and Google. And which today we'll be doing just Azure. It's pretty much the same because we're talking about a containerized environment, right? So so we're selecting AKS, and then the last one is what I was talking about is RTF on a VM or a bare metal, right? It's an appliance model. Use a software appliance bundled with Kubernetes and Docker. So we're just selecting AKS and just name something, and read this because this is going to burn you when you support, right? I mean, who has what responsibility, right? And I think someone was mentioning like who does what here, right? I mean, there are things which has to be done by, if you are a Mule admin, right? Then you do certain things, and then if you have a cloud, if you have a well structured organization where you have a different team doing different things, and then you may have to kind of give them, these are tasks to be done by the cloud admin, and then once they're done, then you do the remaining task, which is the MuleSoft stuff. So there is a, and it also comes to the responsibility during the support, right? If something goes wrong, where do you find the issues are, right? So and who will troubleshoot? So a lot of differences when it comes to who manages what, because Kubernetes is taken care by your cloud team, right? Or who is your cloud admin, they take care of the Kubernetes. You're only responsible for that Mule container or Mule pod running inside, right? Or your application running inside. So if an issue happens, and I kind of deliberately skipped something called external log forwarding, right? So what it does, and why do you need to worry about? Because the first thing is to go see the logs, right? And then if your log says your application is fine, then you can say, pass the ball to the cloud admin team. Say, hey, your Kubernetes is running out of resources. Assume they have enough, alerts configured, something like that happens. But again, there is a responsibility which has to be split when it comes to supporting this overall platform, like MuleSoft versus Kubernetes cluster on running on AKS. So you accept. Now you see there's it's ready for activation. So now it has an activation code here, right? This is an activation code. So I copy that. So this is my activation code. So I need that for my installation, and you'll see how. So the first, second. So let's get into. So we got the credentials, right? We created the resource group. We have created the cluster, and we got the credential to our CLI. And the next thing we'll do is to validate if everything is required by this installation is ready or not. So for that, you head back to your RTF CTL command, and all you have to do is validate. And what are you validating here? So this is the activation code. So the activation code is kind of links. We remember the previous step you got the credential, right? So now you have all the configuration needed. So now your configurations are talking to each other pretty much. Like you have AKS cluster, and this is an activation code for your runtime fabric you did on runtime manager. and now these are connected. And when I do validate, it does pretty few things. It checks if the Kubernetes environment which you will be running is ready or not, if it's running or not, all the required components, if they are existing or not, if the Kubernetes services are available or not. So basically, it's kind of cross-checking to your AKS cluster and making sure that everything is there. And if you see here, it did some additional endpoint networking check, right? If you see this endpoints where you see AWS, right? We didn't do anything on AWS, right? Can someone answer why is it doing AWS stuff here? We did Azure, right? Okay. So remember, in Cloud Hub, your Mule control plane, like the site, what we just checked, all this, right? This URL here, everything is on AWS. That's how Mule manages it, right? So basically, it's kind of pinging to that control plane and making sure that there is a connectivity between your Azure and this AWS. That's why just doing a tick mark. It's a connectivity check with the control plane of Anypoint platform. Okay, and then I think that's all. RTF, there's some software, messages here, which is RTF new version and all that. You can ignore if you want to. Okay, now we are ready. So now we'll do the validation fast. Now all we have to do is install, and you'll see how easy and quick it is. And then put my activation code again. Installing the runtime fabric components. And remember, I told one thing before that this is an agent-based architecture, right? And RTF is the name of the agent, right? Which is kind of running in all the nodes and make sure that they're all connected in that cluster. And that's the agent. What you see here, waiting for runtime fabric to become ready. Agent, comma, Mules cluster IP services. So these three are the Kubernetes, the runtime fabric resources or services. There are three of them. One is agent, one is the cluster IP services, which kind of cluster, and the resource cache. I'm not looking at the chat window, so feel free to unmute and talk.
நாங்க தேவட்ட இல்ல நீங்க ஐடி தானே சிவில் சிவிலா
Okay, I think it.
நம்ம தினம் ரசம் சாப்பிட்டோம்
I believe, yeah. Thanks.
Okay, so your runtime fabric is ready, and let's head back to the platform and see what changed here. So if you see here, it took barely a minute or two to install, and see this is what we did. RTF AKS demo. It says register. It will take a little time to kind of show up here. The status should be active. It says register right now, and then so we'll give it some time. But in the meantime, just I'll show you before and after. So we can associate these environments. We can associate a runtime fabric to a number of environments. Ideally, the best practice is just to keep them with, if it's dev, keep your dev and production separate. But yeah, you can connect this, use this for sandbox or you can share across environment if you want. Okay, now the status has changed to active. So now this agent, see, this is what was happening. Your agent was communicating with this control plane, and that's why it took a little bit of time. And your inbound traffic, you see, So this is where the discussion about or you need to configure your Ingress controller because now it's in a cluster, right? And how will it route the traffic to the pod? So you need a traffic routing mechanism which is being provided by this Ingress controller. It says you cannot use your endpoints unless you configure that Ingress. And log forwarding, you need a titanium subscription if you want to use Anypoint monitoring. You don't have to if you don't want to. You can. There are many other ways. Either you use the platform provided log monitoring solutions, or you use Splunk for Kubernetes, or there are many ways you can do it. Or the pods are logging to the standard out, so std out or console. You can always do a kubectl and do logs, and then go to that pod and you can do all that stuff. There are many ways you can do that. Okay, so now this is ready. So let's verify your cluster is ready. Status, active serial status. And then once you know if the cluster is running, and which we'll see. So it dumps information around this. This is the component I was talking about, right? It's an agent, runtime fabric information. So you have agent running LC through, cluster IP through, resource cache through, and one more thing I would like to pay attention, or I'd like you to pay attention here, is I think that's what pretty much. And these are all connectivity to the control plane. And your role is an agent, which is this runtime fabric is running as an agent, and these are the components. I think that's pretty much it. Now the next step for us is to install the license. The way to do that is as simple as RTF curl, and as I said, like you have a trial license, get that trial license, but and here don't type license.lic file. You need to do a base64 encoding, right? You can do that in Windows or Linux. The way to do that is go back to your environment. I mean, any of the Linux environments. Do a base64 W0, which does your encoding, and then your license.lic file. So it will give you a base64 coded license, and then you paste that up here. So for a moment, you will have to stop sharing because I'll be applying the license. So to RTFCTL, apply new -license and your base64 license. Okay, your license is updated for me. Let me share back. Any questions?
Yeah, Mani, Amit this side. One question.
Sure.
So you are showing all the commands and doing the like through RTF CTL. Okay. So do we need to apply any client certificate on the RTF CTL to properly configure and to run this command line? Do we need any like configurations?
No, you don't have to.
Come again? We don't, or we have to?
No, you don't have to because I mean when in your kubectl or Azure, I mean when you install this command, right, and then I think I did. There is a step to configure for that. I'll take it back. I think there is. See, basically, when you log in, right, it will prompt you to, it will open up that Anypoint MuleSoft login page, and then that's where you type your username and password, just like what you do with Azure. So you don't put a certificate. It's basically like, oh, the moment you launch that, it will ask you to sign in, and it'll take you to your Anypoint platform sign-in page, right? Yeah, that anypoint.mulesoft.com, where you sign in. Once you sign in, it stores that security in that config file in your local machine, just like you do AZ. If you do AZ login, it just like same thing with Azure login too. Like, you don't have to provide a certificate. Those are old technologies. I mean, nowadays it's all done through like if you do AZ login, it will open up a browser, and then it's OAuth based, right? You see OAuth/authorize. So similarly, you will also. I've already done that.
Okay.
So it caches in your credentials in your in this laptop.
Okay. So once we open the RTFCTL, then we need to log in through the AZ login and on the browser. Once we log in through Anypoint, and then we come back on the command line and then run the
Yeah,
commands.
I mean, I'll just show an example of AZ. AZ login is not related to RTFCTL login. Those two are different, but again, the same principle applies here. Because how will your command know to connect to your Anypoint platform, right? How will it know? What is the link? So the link is through, when we launch that command, it will RTFCTL, it will open up a browser similar to what Azure will also do. But I'm saying the technology has now moved to these kind of authentication where it's OAuth based, and it will allow you to sign in. Once you sign in, the control comes back to your command line and then caches in your credentials in this machine. Like I was showing a kube config file, right?
Okay.
It's the same thing. It goes inside that .config files. I think I should have a what you see here. This is all the configuration file. It caches in up here. I think I should. There's a kube config file here. See this RTFCTL file?
Yes. Yes, I can see.
Yeah, that stores everything. So it kind of creates a cache of your credentials. Same thing I was showing before. I also have a Azure file here, and there is a kube control file. All that are stored here.
Okay.
Okay, so yeah, I did install the license, and the next thing is we need to attach this to one of the environments. I see all these are healthy. Now we link it. I'm linking this to a dev environment, even though you can link to as many as you want, but not a best practice. Right, so application is, our environment is ready, but there is one thing we have to do before we even deploy any application, because we need an endpoint, right? If you're deploying an application, it will open up an endpoint so that you can connect from Postman or through HTTP. So you need an endpoint, and for that endpoint, I was explaining before, this is a cluster, right? So in a cluster, you have many nodes, and nodes has pods. So how will it go to the right pod running your application, right? So you need something, a routing mechanism, or think of that as a tiny little gateway, which has to route the traffic, right? Which is the Ingress controller, and that's what we will do now. So we'll create an Ingress controller. So just to show where we are in our list of things we planned, we did number one. I did before. Number two we did. Number three is where we'll be doing a configuration of Ingress controller. And as I was saying before, and I'll kind of repeat a few times as needed. So Ingress controller is a gateway, right? And it's being provided. You have many options when it comes to Ingress controller, right? Remember, it's a customer managed, right? You are responsible for it. I mean, when I say you, it's like a different team within the organization is responsible for it. So they can choose. If a cloud admin say, you know what, we already have Ingress from some other company, yeah, feel free to do that. So it's for them to decide. But yeah, right now for demo, I'm using a pretty a community supported Nginx Ingress controller. And the way to get that Ingress controller is, if you see there's a deployment YAML, and I'll just show you the cheat sheet. It's a long command. So I'm getting it from raw.github usercontent.com Kubernetes, then Ingress-Nginx controller version 112. I'm getting that YAML file. I'm getting that deployment YAML file. So, and this is what it looks. a deployment YAML file for the Kubernetes after in Nginx Ingress Controller supported by Kubernetes community. And so API version is v1, and then you have many things you're creating here. Like it's a deployment file, right? It's an installation file. It's a pretty long, big one. You don't have to worry what goes inside. All you have to do is get this and apply. This is how you install something in Kubernetes. Just get that deploy YAML file and apply that. So a new deployment has been created, and it's saying unchanged. I will say if you do it first time, it'll say created. So basically, you're creating a namespace. Remember, a namespace in a Kubernetes cluster is very critical, and we'll learn soon why. Because and see how our our environment looked like so far. Right? We did create a cluster, right? And then we also created a Kubernetes runtime fabric in that cluster. We just created an Nginx Ingress Controller. So we have three things: a cluster, and then we have inside of cluster we have RTF, we have Nginx Ingress Controller. Let's look at our cluster. kubectl cluster info. It will give me a bunch of information. So it's saying there's a Kubernetes has a control plane, which is fine. It doesn't really matter to me. So maybe the better command will be to look at the pod. So and keep these commands, and you can just Google Kubernetes cheat sheet, and you don't have to memorize. I mean, they're basic commands, and so I'm trying to get all the pods, because pod is a very basic object when it comes to Kubernetes, right? And see what's happening here. Zooming in. So first thing, you see the namespace. So namespace kind of creates a logical separation between the resources in each. So we see three namespaces here, right? One is Ingress Nginx, right? In that namespace, we have only one resource, which is the Nginx Ingress Controller, and you see status is ready, running, and age 4 hour. I did that earlier today, just to make sure the demo goes smooth. Yeah, it's running. And many times, if you have something wrong, sometimes you apply a bad license. You know what? You'll see this running restarts many times here. It's kind of stopping, it's crashing, and restarting, stopping. It goes in a loop. You'll see the restart counts high, and that's why you have trouble. And then you see ready, it's turning from 0 of 1, 2 of 1, sorry, 1 of 2, something like that. So you know there's something is going on. But anyway, it's all clean slate. Nothing is wrong. And kube system is all about our AKS cluster. All of these. And you see some disk node, core DNS, Azure IP, all that stuff. The metric server, all that. Again, it's not our headache. If anything kube system goes wrong, it's not our. Just immediately contact your, cloud admin. And then this is what we are concerned about, RTF. So this is the namespace for all the runtime fabric related stuff. I mean, the runtime fabric system components. When you deploy an application, it will have its own namespace, right? So that's nothing to do with your RTF namespace. RTF namespace is where your three things. If you remember, we had three components within RTF, right? When I did what did I do? I did a RTF CTL status. It was showing me three components running, which is agent, right? Which is like a cross node feature, which is running in all these nodes and connecting sharing the information, right? That's a critical component is your agent. And your cluster IP services, it provides an internal IP address for them to communicate. Resource caching mechanism, as the name sounds, so this is one. These three are the critical part. Other than that, the remaining are not of so much importance. And so looks okay. And now one small thing have changed. Remember, we were doing this in our RTF AKS, in our cluster. It was showing inbound traffic. First, go ahead, and it was suggesting us to do the ingress configuration. So only then it will route the traffic, or it'll enable an endpoint. So let's just refresh and see where we stand there. Okay, you know what? We just created an Ingress controller. Basically, we installed it. We haven't configured that, right? So installation is done by doing a kubectl, apply -f. So basically, that's how you install stuff. Now we need to configure that Ingress controller. And one thing I would like to mention here, like why do we need a custom Ingress? What we're doing now is getting a custom Ingress template, right? Not out of the box. We're getting it from Kubernetes community, putting our own Nginx Ingress controller, and there are few things you get out of that. You can pretty much configure many Ingress configuration per application. Let's say you have an application which has many endpoints. Let's say, and you have an API, or like let's say you have a bunch of APIs for application. You have 5 system APIs. You have 3 experience API. 2 process APIs, right? And all of them you want to have one common endpoint, like a base endpoint, right? And then you can do that. You can put um, different endpoint configuration. So you can pretty much do multiple Ingress configuration per application based on your endpoint needs, right? You can do that. And you also do, remember I was talking about Ingress controller. It provides you like a security mechanism. This is where you do your TLS, HTTPS, all kind of security configurations here. You can do that all from that template file. And also you can do a path-based routing. Let's say you are exposing these applications, and why don't I show you that template? I think before I start just talking, this is the template we're going to use. This is how we configure a template, right? So template for Ingress. So you see, this is the kind. What kind of template is this? It's the Ingress template here. Kind is Ingress, and there are some annotations here already given here. And this is where I'm rewriting app name. These are the placeholders, and I'm trying to do a dot star. So this rewrite is a feature of this Nginx controller, unique to this. Other Ingress controllers will have their own annotations. This annotation section kind of provides you their own specific way of configuring that particular Ingress controller. So rewrite is part of that, and you are basically renaming the app. I mean, you are kind of messing up or kind of customizing your path here. And name is RTF Ingress template, and I kind of told you many times, it's like this is an agent, right, based system, right? And the agent is RTF, and the namespace is RTF. So anything you want to do within RTF, you have to prefix this namespace. So you have to prefix RTF, then anything else. So that's how the agent knows to act upon it. If I change here, if I remove this RTF, this won't work, because then the agent, the agent will not recognize this name or this resource. It cannot communicate if you remove this RTF hyphen from here. And then the spec is again Ingress class name. You see RTF being prefixed here. That's how I just mentioned. You have to prefix RTF with the Ingress class name or many of the resource name here. And the host here, I'm just taking as default rtf.example.com. And for you, maybe let's say you are a auto shop or something, right? You put whatever your networking team suggests this name to be. You work with them and figure the name here, and they will do the DNS routing for that. So that you get it from them. So for the demo, I'm just putting rtf.example.com, and this is a path-based rewriting, right? So this is app name is a placeholder. So pretty much whatever your app name will be replaced here. I mean, when this runs, because you are doing a configuration, this is the dynamic part. And below that, this backend services, all that, it really not used for any configuration, or it's not used by the RTF agent, but yeah, it's needed for the Ingress configuration. Okay. Any question? Okay. So now the thing is that we need to apply this, right? So we apply this, and the way to do that is to kubectl apply f, and this name is ingress template dot yaml. Okay. So it created, and now we should see that changed here. Oh, it already changed. So if you see this is what we just created, right? We created an endpoint. App deployed to this runtime fabric can accept requests to these endpoints. Okay, so this is what the host name we just gave here. And remember, you are still configuring your RTF environment. You haven't gone to deploying an application yet. So now it's the time we're done with the configuration of this RTF. And now the step is for us to deploy an application. Number 3 is done. We configured an Ingress controller, and now we'll be deploying an application.
Hey Mani, Amit
Yeah.
this side. So
Yeah.
as you deployed the URL, it works only on HTTP, not on TLS, like with HTTPS.
We will do that. Yeah, that's number 5 and 6. Good question. So we'll do the security in the cloud. Right now it's all HTTP, no security yet.
Okay.
The plan is to deploy application non-secure and then add security step by step.
Okay. And just one doubt, like mostly log forwarding in RTF, it comes with the Titanium membership, right? So if like a client wants, then we can install easily the Splunk in the Kubernetes and get all the logs for the Mule.
Yeah, when it comes to logging, it is a ton of things you can do. If you guys have Azure, like if you are already using a log analytics from Azure, you can certainly, like, if you go here, you have your logs here, and it basically it depends. You want to pay Azure, or you want to pay Splunk, or you want to go pay MuleSoft, right? When it comes to log forwarding, everyone can do it. It's just a matter of your choice. If you
Okay.
do Titanium, you already have a Titanium subscription, then we just have to enable that because you already paid for it, right?
Mhm.
And if you have a Titanium license or like a Nordic Titanium, right? Then you can, or you have Azure and you're leveraging a log analytics workspace, you can do that. So if you see here, container logs, auditing, all of that are available to you. You just have to select Mule application as a level. That's
Okay.
how the pods are named. So you have a wide variety of choices when it comes to logging.
Okay.
Okay, so now deploy the application. Yeah. So I'll just do a basic deployment of application and hello world. And see your deployment target. Now you see this RTF AKS demo popping up here, right? And see this. So this is what you'll also see when you do select Cloud. If I select Cloud Hub, I see runtime version, worker size, which is the CPU, and number of workers, right? And if I change to this, I'm getting a runtime version and replica. You don't see that. Yeah, you see it here. Your CPU, which is that number of workers is basically your replica, and where you see here, right? This is equivalent to number of workers, and this is your the worker size, right? In Cloud, which is basically a CPU. I'm just taking a default. I'm just doing a hello world. I don't need to over allocate things. And rolling deployment model, this is the same thing in the Cloud Hub also. Either you do rolling update or recreate, all of that good stuff. Okay, I'm going to do 2 replicas here, and let's pick up the hello world. I'm just being lazy and getting it from the exchange. So go to exchange, type hello, and you'll see a hello world here. Okay, and then yeah, here is the interesting part here. So this is what you see the URL, right? Now remember in our Ingress template we had a app name here, path app name, and so that's pretty much is this. The app name, which is hello world 04142022, is being appended here, and you can change that. It's not a mandatory. You can change it here. You can add multiple endpoints. Keep on adding endpoints as you need. This is what I was showing. Like you did one Ingress controller, and then you can have multiple endpoints. So you can. So that's the beauty of it, having a custom Ingress template. Yeah, nothing else. I don't have to do anything else. Ingress is fine. I'm just deploying it as is. So I have two replicas. So the moment I do that, if you see here, get pods, and see that ready status is 0 of 2 on the top. And it created a deploying an application, just created a new namespace, like 45544BC6F. And you see the application name hello world, and it shows ready 0 of 2, right? And status is init 0 of 1. And 2 seconds. I kind of wanted to show you quickly how things are changing here. So 0 of 2, 0 of 2, there are two replicas we created here, right? And it's just initializing the container. The pod is being initialized. So that's why you see init. Now by this time it's already deployed, so you'll see things changed. Oops, it's saying something. That's where the fun part starts. Image full backup. That shows not a good sign. Yeah. Okay, now it's ready. 1 of 2 status running. 2 of 2 status running. Keep checking. Yep, I think both are running fine now. 2 of 2 running. See this? How it's progressing. So each of these replicas um, are taking its time to go from init to running. Yeah, 2 of 2 running. Okay, so now let's go back. This is our hello world application. And if you see replicas 2 of 2 started, right? So it's all good. Okay, so now we deployed an application. The next step for us is to secure the traffic. And what traffic we're going to secure now? We're securing the front end of the traffic, which is a Ingress controller to the client apps, the front end traffic, right? That's what we want to secure now. And the way you want to secure is, again, remember that the advantage of doing an Ingress controller is that you configure that security in this template here. So all you have to do is yeah, this one. I'll show you the one. I have just modified that template and so I'll show you before and after. So this is the Ingress template, right? We used first, and here all I'm doing is adding a spec TLS. So we had it here. All we inserted a section here, which is the TLS. TLS host is rtf.example.com, and so that's the only change between these two. Adding a TLS configuration here. And secret name is example TLS. So for that, well, we missed one. I think I missed one step. So I deployed an application, but I haven't tested it. So let me go back. So the application is deployed, and the way you kind of test it is using curl. And remember that we have an ingress controller, right? And ingress controller kind of exposes a public IP. And for the command to get that public IP is yeah, we need to get the public IP address of that Ingress controller because that's a front facing, and the way we do that is Kubernetes get services -n ingress nginx. If you do that, you will get an IP address, external IP address, and you see here. So that's the external IP address I'm talking about. So 20.121.253. So I will just replace this. I'll just do a curl now. And if you look at this command, this is the name of the application. So I'm going to do a curl. So what I'm trying to do here is I'm using curl to resolve, right? I mean, you don't do that in a enterprise environment. You basically go talk to your cloud admin and tell them to resolve this IP address or resolve this domain name, right? But yeah, I'm just using for demo purpose. I'm just using a curl hyphen resolve to resolve this domain name to this IP address, which is what Ingress Nginx controller gave me, right? So if I do, I see a response here, hello world. So it's working. So we're able to access that application from outside, but it's not secure. I'm doing HTTP. Now we're going to secure it, right? So, and then I was talking about applying that template, and you saw that template. It's not here. All we're doing here is we're going to apply a Ingress Tls template. What is the name? Ingress Tls. I think Ingress Tls. Ingress-tls.yaml. Right? Is that the name? Ingress-tls. Okay, so we're applying a security to that Ingress configuration only for front-end traffic. Now instead of doing HTTP, we will do HTTPS. And now head back and refresh and see what changed in this application. If you see Ingress, yeah, you see this? You see an S here? It changed to HTTPS because you just applied a security to the Ingress controller. So basically, you just doing the first log, what you see here. Oops. We're securing the traffic between the client apps and the Ingress controller. So we are securing this Ingress controller, putting a TLS. Okay. So now let's head back and then do a curve. So I have ready. Oh, I missed a few things. So we this one thing we did, right? We did use the TLS, right? We applied that to the Kubernetes, right? And one more thing we need to do, because this is the configuration we did for the Ingress controller, right? Then we also have to provide certificates, right? And for that, we need to generate certificates and private keys. And remember, one thing you noticed here, there's a secret name here. We did TLS host artifexample.com, and then there's a secret we need to create, which is the example TLS. So this is what we need to create in Kubernetes, and the command for that is um, Yeah. Anyway, so we need to generate a certificate, right? And that's the command for this is the command which creates a certificate. OpenSSL, basic. It's what it's doing here is giving a key, which is key out key.pem, a certificate, basically a cert.pem. And once I take that certificate and see it's the common name I'm referring here is the rtf.example.com. So I'm creating a key, creating a certificate, and we will use that certificate and the private key what you created from this tab, which I've already created. I'll just show you that. So this is my cert.pem and key.pem I did long back. So you use that command, it gives you these two, and then what we need to do is using that certificate and the private key. The last step is to create a Kubernetes secret, but that secret is what I was just showing you here. Ingress example.-tls is the secret name. So this is what we need to create. And the command for that is kubectl create secret and the name secret. What kind of secret we're creating? We're creating a TLS secret, right? TLS, and the name of that is example-tls, and which namespace we would like to create. We will create in a RTF namespace because that's the key part here. And the key we had was key is what key.pem, and I need the cert, right? So cert is cert.pem. Okay, so that is created, and it's created inside your cluster with inside of that RTF namespace. It's not created in your local, by the way. So it's there. And the next thing is we will reapply. I should have done that before. Yeah. So we have both. We have because the previous step was not having this example TLS. I just created it. Then I reapplied that Ingress TLS template, which was referring to that secret/example TLS. So we're good now. And so do I have to do any change in my application? No, because I'm not touching the application yet. I'm only concerned about the traffic between the client apps and the Ingress controller, right? And what we just did, secured the Ingress controller with that TLS. We provided a TLS spec, and for the Kubernetes cluster, we created a secret example.tls. Sorry, example-tls. So we have, so these two is what we just did there, right? And now I can safely go ahead and do the same hit the same application, but now I'll be hitting its HTTPS endpoint. So which is, so pretty much this is what you see in my screen. But let me remove that IP address or replace that IP address.
Hi, Mani.
Yeah.
I'm at this side.
Yeah, go ahead.
So, like one doubt, like when we are deploying the various APIs, okay, and it can be multiple numbers. So every time we need to resolve this IP address by
No,
this
you don't have
command.
to. You don't have to, because what I'm doing is just a demo, right? I mean, once you have your this RTF example, your cloud admin team kind of take, or networking team kind of takes care of that. Let's say your client is Ford Motors, right? You say RTF or whatever the base URL you have, you already provided that, and your DNS, the networking team would have already resolved it. So you don't have to do this. Assume that this API, this name is accessible internally or externally. Depends how you want to expose these APIs. You simply go to Postman and hit this URL. That's it.
Okay.
Yeah, you don't. This resolving is I'm doing because I don't have a DNS here.
Okay.
And one thing you will, yeah, I mean, that's a good question. I think we're doing too many steps, but it's literally not required what I'm doing now. If you have to do in your enterprise, you don't do this curl resolving all that stuff. But now see, what I'm doing here is I'm kind of doing a 443. I did 80 before, right? To HTTP. Now I'm doing HTTPS, but doing a 443. and I'm putting a -v to make it verbose. Oops. And yeah, we got a hello world back, but see what all happened. It's saying Kubernetes Ingress Controller fake certificate because I just made up a self-signed certificate. And all you see all this TLS handshake, client hello, and all that. It successfully set certificate, verify location. So all are good. It's trying to connect to this public IP. So we're able to hit the application now. So this part is done. Now we will go back and secure the backend of the traffic. Now we did the front end traffic with this first log. Now we will do the security. We'll secure the traffic between the Ingress controller and the Mule pod, the application. And one thing I would like to highlight here is that, you know, ideally in a cluster Kubernetes cluster world, you can pretty much kind of package many different kind of containers inside of a pod. But when it comes to Mule pods, they are pretty much exclusive. So you cannot add any other container inside of this, any other non-Mule containers inside of this Mule pod. So just I would say that's a big difference. Okay, so we're securing the traffic between the Ingress controller and an application. And there are two things you need to do. Just like if you remember, to securing the traffic between the Ingress controller and the client apps, we did two things, right? We applied a TLS spec to the Ingress, and then we created a security, a secret basically inside of a Kubernetes cluster, right on the bottom here. Right, so because you don't directly, the client app does not come straight away to Ingress, right? It hits the Kubernetes cluster, and from there it hits the Ingress controller, right? So that's where you had two things to be done. Similarly, when we are securing the traffic between Ingress and the Mule application pod, we need to do two places. One, we need to secure the application, the Mule application hello world, and which you guys have done many times. Put a global configuration, put a TLS, HTTPS port, all that good stuff, and then we are supposed to route the backend traffic, and we need to specify that the backend should be listening only on HTTPS, and this is how it looks. And I will again to show you a side-by-side view of what it was and what changed. So this is what we had. Okay, and annotation. So basically nothing, well, quite a few changed. First thing is this TLS, which we did because you are still securing the front end traffic, right? This section is for the front end traffic TLS, and now we are adding. And remember, this annotations are specific for that specific ingress controller. In this case, is Nginx. So you see Nginx.ingress, and we are adding this annotation here, saying that Nginx ingress Kubernetes / backend protocol HTTPS. So this tells that connect the backend using HTTPS. It's as simple as that, and all we have to do. But one thing you notice here between this and C, I didn't see, these are all vague here, right? I just have hyphen and all that. The reason is this is not really being used by, so we are okay not to specify much here. So I'm going to apply this to the Kubernetes cluster, which is the copy file name to clipboard. Okay. So we applied that. So again, it's just one step of securing the traffic, right? I mean, this we just applied this configuration to the Ingress. So what about the application? So application, you open up this help application and do some basic stuff of securing the traffic. Now, just like any other Mule application secure, put a global configuration, put a TLS, give a key store, all that stuff. I mean, I won't show that. I mean, just a very simple thing you guys should have done many times. But again, just to summarize what I did, I created a self-signed certificate, and I created again one more key, one more certificate, and kind of packaged them together in a key store. And I'm calling that key store as a keystore.p12, what you see here, and it's a type p case. This is what is the standard, and then I have a password and all that. So this is secure. And one more feature I would like to highlight here, the HTTPS port. You'll notice here I'm not using 443 here. I'm using 8081. If you remember, in Cloud Hub, you have 8081 and 8082 for HTTP and HTTPS respectively, right? But in for RTF on cluster, you cannot use 443 here because that's already being taken by your Ingress controller, right? That's already using 443, so you cannot supply that. You can only use 8081 as an HTTPS port. So it's a bit different, but that's how it works. And once you do that, you just export that into a jar file and then deploy that again. So that's the second part of the configuration. So let me go back to the application, and I've already created that. So I'll just upload a file. Anypoint Studio. Namespace. Studio. Where I kept it. Well, we'll generate one more. No big deal. Oh, yeah. See MuleSoft RTF. Yeah. Hello world HTTPS chat. Okay. Not changing anything. Save. That's a bit interesting. Somehow it doesn't allow me to apply change. Is it error? Oh, okay. I know why this is complaining. Okay, so we did HTTPS, right? So it's saying this template that this endpoint users has been removed. Please change it or remove it. So you're saying, okay, go ahead and use HTTPS, right? And now it should allow to apply change. I think we are almost done. So this is the final step. So Sadiq, you still there, right?
Yeah, Mani.
Yeah. So the next step is we're deploying this, and we will. And remember one thing: we did not change how we use the curl. We didn't change how we access this. Right? We are still accessing over the same HTTPS port. The only thing changed this time is our application is made secure, backend traffic is made secure, right? So pretty much we'll use the same curl command we used last time. And again, ideally in an enterprise application or in like a production grade application, you don't use TLS. There are better ways you can handle. You can use auth or a token based or SAML. There are many ways. There are many better security mechanism you can use. I'm just showing for demo like this basic TLS, but that's not what you will do. Okay, so here is your endpoint, and it's ready. So we'll just hit that again. As I said, there's nothing changed from how we access this application from the front end side. We should still get a hello world back, which we got. Okay, so this is how you typically. So what we did here is all this, right? We created a cluster. We created runtime fabric inside of that, and we created an Ingress controller. We configured an Ingress controller, and then we deployed an application, which is the Mule pod, and then we secure the traffic both from the front end between client apps and the Ingress, and then Ingress to the pod, and tested every time we changed anything. So that's pretty much it. And yeah, one more thing before we, any question before I kind of start showing how to uninstall and all, because I'm going to wipe out everything. Oops. Okay, so the last and the final part is to clean up, right? So all we do rtfctl and put uninstall, and it's saying okay, do it again, just like the way of saying okay, confirm. Okay, confirmed. It's going to remove from that cluster. And remember, we are uninstalling only rtfctl. So as you might have guessed, it's only going to remove the RTF namespace from there. It will not remove the Nginx Ingress controller, which we did. And this is where your job separation comes between a MuleSoft admin versus a cloud admin, right? You are only responsible for that MuleSoft component here. You're only removing the RTF components there from that cluster. And the remaining clustered resources you still will have your AKS cluster. That something has to be removed by the cloud admin. You'll still have to remove that deployment we did for Ingress, which is again the customer's responsibility. In that case, in this case, it will be cloud admin's responsibility. So after this is done, so anyway, let this continue, and then we go back and remove our runtime fabric. Now, because we are removing things, it should complain. It's still running. Yeah, it takes a while to change that status.
Yeah,
Still,
sometimes.
okay, we can. So, Sadiq, how would you like to do? Shall I bring up the quiz?
Yeah, good. And we have two approach. Either you can share question, and whoever going to answer first in the chat, they will be the winner. Or we can have the Kahoot board as well, whichever you like to go with money.
Yeah. So this is our team here. We have Bill is our director, and Rob Raston. If you have any business questions, you can reach out to him. This is his email address, and myself, I'll be always reachable by my email address mrothroy@xtbi.com.
Okay.
First quiz.
Yeah. So we can just to clarify the rules once again, team here, that we going to choose the three winner from this question, all the questions which money is going to ask, and whoever going to share or give the answer first in the chat, we will choose as a winner for them. And so we are going to have 2%, 3% for the winner. So go ahead for that. Thanks, Mani.
Yeah, thank you, David.
So we have 10 more seconds to respond. Three more seconds, and that's it. Okay. So what is the answer, Mani, for that?
So I think people have answered 1, 2, and 2. Okay, so far. So this is an interesting question. So which I have talked about many times. So select all that are specific and unique for an Nginx-based Ingress resource template. This is a bit difficult question, I would say, because see, we all know so far that what is an Ingress resource template, right? It provides all these four what you see here. Any Ingress resource template custom will provide a multiple Ingress configuration per application. Yes, you can do TLS and HTTPS configuration. Yes, we saw that. Rewrite annotation to do a path rewriting. Well, this is a unique one because I remember that I was talking about when I was showing that annotations, like see these annotations up here, like for example this backend HTTP and this rewrite keyword, and this is specific to Nginx. It's an Nginx specific annotation rewrite. So this is only thing unique to Nginx. Even though there are many other ways, other Ingress controller will have a different way of rewriting this backend URL, but this is unique to Nginx. URL parameter placeholders everyone provides, nothing specific to Nginx. So the answer is number 3. Okay, and I didn't expect everyone to answer this. I briefly talked about when I was speaking about rewrite.
Yeah. So believe there's no winner for this question, right?
Yeah.
So let's go for the next question.
Okay. Here's the next. This must be an easy one.
We are giving 20 seconds to respond here. Please give your answer.
And select all that is applied. So you have it's a more than one answer, or maybe only one.
Mani, I'm leaving on you to choose the winner for this answer.
You can go ahead and do that. I'll explain the answers. I think once the time is done up, you can say announce that.
Okay. So we have 7 more seconds to respond. Yeah, that's it. Yeah, Mani. What is the
Okay.
answer? Yep.
So I talked about. So let me see what people have answered. 1, 2, 3, 4. 1, 2, 4. So where do I start? Okay, so 1 or 2. So it starts from Rakesh, right? 2, 2, 1, 2, 3, 4, 1, 2, 4. Okay, I think Avinash, you are right. So Kubernetes, we all know, and just like a standard Kubernetes pod writes to std out, which is your console, you can do a kubectl logs to view logs, right? It's a very basic rudimentary way of seeing the log, but yes, you can monitor logs that way. Number 2, you can forward with if you have a Titanium, right? You can see that in Anypoint monitoring. That's also correct. Use Op Center for monitoring the pod logs, and if you remember, I spoke in that Op Center is only to be used in conjunction with RTF for a VM or bare metal, right? It's not available for RTF or Kubernetes, right? But it's not correct. It doesn't. It's not applicable in a Kubernetes cluster because the question says MuleSoft application pods inside of a Kubernetes cluster. So you cannot use. Well, so Op Center it's not relevant in conjunction with RTF on AKS. Number 4, use Splunk for Kubernetes. Yeah, that's you can bring your own tool. So that's also correct. So 1 to 4 is the answer.
For brief explanation. So we are going to choose Avinash is the winner for this question. So you can go ahead for the next one.
Okay.
Yep. Yep. We have 3 more seconds to respond. Yep. We are good now, Mani.
Okay. So this is easy, right? And Ingress Controller definitely is a customer responsibility. External log forwarding is again customer responsibility. When I say customer, it's like think of this way: it's like a split between what your MuleSoft team versus your your cloud team. So yes, 1 and 2, it's a customer responsibility. All of the above is not correct because runtime fabric agent is what the Mule team has to worry about, right? So its answer is 1 and 2.
Thanks, Mani. Dheeraj, can you send me your email ID 1 to 1? Thank you so much, Mani, for helping us to find the answer.
Yeah.
Yep. So Dheeraj, I'm going to make your name.
Yep, that's where we come to an end of the session. If you still have any questions, I can take up questions if you have.
Mani, I would like to, you can ask one more question so I can wrap up the last winner because I still need to choose one more winner for that.
Oh, so I'll show a new question.
Any question you can ask and
Yeah,
then we can answer that so I can
did
choose
a
another.
presentation for Atlanta, so I'll bring up that slide. There is a question there. If some of you have attended my session before, then I think you can answer that. But nonetheless, I'll bring it up. So be ready for the question. It's pretty easy. Question. Yeah, here is a question.
Okay.
And type the answer. I should have, or you can just say 1, 2, 3, 4, and then type the answer. Either way.
I believe we have 5 more seconds to respond here. Yep. Mani.
Okay, done.
Yep. So what is the answer?
So Krishna, number 3. Oh, Krishna only. Okay, I think Krishna, you're right. 881 for both HTTP and HTTPS. Because what happens? The first one is true. This first one is not even correct in any context. Number 2, 8081 for HTTP, 8082 for HTTPS is only true for Cloud Hub. And number 3, 8081 for both HTTP and HTTPS is what we just saw, right? Because that's 443 is taken, so you cannot use that. And the last one, 8080 for HTTP and 443 for HTTP is not correct because 443 for HTTP is not correct at all in any sense. So
Thanks so much, Mani. for the presentation and giving us a brief introduction and practice and approach for RTF. Hi team, who I have mentioned the name, please share your email ID one-to-one if you want. Completely okay. And Mani, if possible, you can share with me the recorded session of the demo, so I can upload into